Hey guys, welcome to Math for Kids by a Kid. Today is a sort of continuation from last lesson. We are combining the exponent laws and looking at simplifying expressions with coefficients and variables. So I'll show you an example of what we're going to learn here. So let's say we have to solve 3a to the power of 3 multiplied by 3a to the power of 4. In both expressions, 3 is the coefficient and a is the variable. In the last video, we learned that when multiplying two powers with the same base, we add the exponents. And that's what we would do in this case because both terms have a as a variable. But what about the 3's? We are going to multiply them together. So if we were to simplify this expression, it would become 9a to the power of 7 because we're multiplying 3 and 3 and you get 9, and then we add 3 and 4, which equals 7. So 9a to the power of 7 is the final answer. Here's another example, except this one has fractions in it. So we have negative 1 over 3 times b to the power of 4. Multiply that by 36 times b to the power of 5. We know automatically that if we were to go ahead and simplify the expression, we'll get a negative coefficient because we are multiplying a negative coefficient, negative 1 over 3 in this case, by the positive coefficient, 36. So we are going to multiply 36 to negative 1 and divide that by 3. So we get negative 36 divided by 3. And from there it becomes negative 12. And then we add the exponents on both b's, and we get 9. So the final answer would be negative 12 times b to the power of 9. And this same rule of multiplying coefficients would apply if we were multiplying three terms together. So like 3b4 times 2b times 4b5. We would just multiply 3 by 2 and then that by 4. So the rule applies no matter how many terms you're multiplying, and then you would add the exponents. Okay, so now we know how to multiply two expressions. Now I'm going to show you how to divide two expressions. So 21 times a to the power of 5 divided by 3 times a to the power of 2. Here we would divide 21 by 3 and then subtract the exponents. So 21 divided by 3 is 7, and 5 minus 2 is 3. So the final answer would be 7 times a to the power of 3. I'm going to show you another example of dividing expressions, but this one will look slightly different than the last one. So 4 times f to the power of 12 times d to the power of 3 over 12 times f to the power of 4 times d. The first thing that's different is that there are two variables, f and d. Second thing that's different is that the denominator is bigger than the numerator, so we can't get a whole number from dividing 4 by 12. In this case, we are going to simplify it. 4 and 12 are both divisible by 4, so we can write, so we divide both of these by 4, and we write 1 over 3. And then we would subtract the exponents. So 12 minus 4 is 8, and we're doing 12 minus 4 and not 12 minus 1 because that's not the same variable. So 12 minus 4 is 8. So 1 over 3 times f to the power of 8. And then 3 minus 1 for d, that would be 2. So 1 over 3 times f to the power of 8 times d to the power of 2. And this is our final answer. Now here's another tricky division problem. I'm going to show you two, and this is the first one. Negative p to the power of 10 divided by negative p to the power of 2 with a bracket around the negative p. In this case, you have the same variable, but the brackets are only on the second term. The tricky part is deciding whether or not the answer is positive. In the last video, I talked about how the brackets make the difference and how the exponent matters as well, depending on if it's even or odd. In this first expression, negative p to the power of 10, we know the answer will be negative because there are no brackets around the negative p. In the second example, the answer will be positive because the exponent is even and there is a bracket around the negative p. The final answer will be negative because negative divided by positive is negative and vice versa. We know the exponent will be 8, so I'm just going to write 8. And because the answer is negative, we're just going to put a negative sign in front of the p. And we are not going to put a bracket around the negative p, or else it will be positive. Because again, you have to keep in mind the 8 here is even. So if, let's say we were to put a bracket around the negative p, then this answer would be positive, and that's not correct. Instead, it's just negative p to the power of 8 without any brackets around the negative p. And this is the next example. C to the power of 5 divided by negative c to the power of 2 with a bracket around the negative c. The first expression is positive, and the second expression is also positive because there are brackets around the negative c. And we would subtract the exponents, so that 5 minus 2 is 3, and c to the power of 3 is our final answer. Now, I'm going to show you one more example of dividing expressions, but this time there's going to be something else that's different. So 2 times d to the power of 5 times d to the power of 4 divided by 4 times d to the power of 3. And this whole thing is being raised to a power of 3. So first, we should deal with everything inside the bracket. So we should multiply 2 times d to the power of 5 by d to the power of 4. So that would be 2, because there's an invisible 1 in front of the d4. 2 times d to the power of 9 over 4 times d to the power of 3. Raise this to a power of 3. From here, we would distribute the exponent 3 on both the numerator and the denominator. So 2 to the power of 3 is 8, so that would be 8. And then, based on the exponent rules that we looked at before, we'd multiply 3 by 9, because that's the power of a power rule. So 8 times d to the power of 27 over 4 to the power of 3 is 64. 3 times 3 is 9, d to the power of 9, and this is what we get. And like I said in the last example, you can simplify the coefficients. So 8 and 64 are both divisible by 8, so that can become 1 over 8, and then we subtract the exponents. So 27 minus 9 would be 18. So 1 over 8 times d to the power of 18. And this is our final answer. Thanks for watching, guys. I'll see you soon.